Okay. So, good afternoon. At right now, we have to... Ay, dito. Wala yung... Okay. Okay, so we'll discuss yung as you noted, kailangan natin as I've said in the chat room, no? Sana check nyo lagi yung, ano ba, hindi ba nagpa-prompt yung chat box dun sa, ano, pag nagme-message ako? Or nagpa-prompt naman?
Ga-appear naman, sir.
Lumalabas?
Yes, sir.
Okay. So, ang sabi ni Mapua, we have to complete, hopefully by online, yung lecture at obviously this course, no? Okay? So, we ended last time, no, nung nag-exam kayo dun sa problem na may losses, right? So now we'll have to continue with the next topic, which is on linear programming, or moving on to optimal power flow. So tanong ko lang sa isa, mute mo na kita dyan, ha? Rhea, naririnig ba ako? Rhea? Pag naririnig ako, may audio ka ba? Or pwedeng chat box na lang? May chat box dyan sa, ano, nakakaano ba? Naririnig ba ako? Hello? Or sa Viber na lang, mag-chat ka, ano. Hello, Ria? Para ma-confirm ko lang. Ria?
Nag-chat na, sir. Ria.
Sa Viber ba? O sa ano?
Dito po sa Zoom.
Dito. Okay. Dinig. Okay. How about si, ano? Okay, narinig mo ako ni, ano eh. Si Jay, kakadating mo lang. Naririnig mo ba ako? Jay? Kahit sa chat box, ay, ano? Vanessa, naririnig ba ako? Pwede ba mag-prompt kayo sa chat box sa, ano? Sa Zoom, mayroong chat box dyan sa option dyan. Para malaman ko kung naririnig. Okay. Vanessa, Emmanuel. Sino pa? Yung iba. Si Jonah, si Adrian, naririnig ba? Tristan. Ayan. Kahit hindi na kayo mag-voice. Okay. Si Jonah, okay. Si Adrian. Tsaka si Jay, hindi pa nagme-message kung naririnig. Nag-raise ka ng hand. Ibig ba sabihin niya, naririnig mo o may concern ka? Jay. Jay, may chat box sa baba. Hindi ko alam kung ang ibig sabihin ng raise hand mo ay naririnig mo o may issue ka. Kung hindi makita sa chat box, sa Zoom, kahit sa Viber, sabihin nyo. Para makapagsimula na tayo. Okay, naririnig. Okay. Sige, start na tayo ha. Alright, so you see naman yung, what do you see? Yung PDF ba, guys? Okay, hopefully nakikita nyo. So, now optimal power flow, similar to a load flow. However, alam niyo, ang load flow kasi, or minsan synonymous yung load flow sa power flow, no? Is a process or parang ano yan a mechanism for checking yung how power will flow from generation to load through a set of equipment, either lines, transformers, or through a set or through a network. So kung paano dadalo yan. So pagka nagpa-power flow ka or naglo-load flow, normally it's you fix values. Yung sa mga nakapag-handle na dito ng mga power flow software, I think si Vanessa marunong yata. Okay? So yung mga yan, yung mga load flow, you fix that to a generator. Sabihin mo sa generator 30 megawatts, sasabihin mo sa load ito 20, so to another load 20. Then you'll run parang usually a power flow software, and eventually you'll determine, okay, how does power flow from generation to load, and you will eventually know, sobra pala yung kunwari 20 nga yung load ko pero 30 yung in-schedule kong gen. Upon performing the power flow through the network, lumalabas ang loss lang pala is let's say 3 megawatts. So you have 20 megawatt of load, and then for power to flow from the generation to the load na 20, 3 ang losses. So sobra-sobra. 30 yung in-schedule mong generator. As opposed sa dapat 23, load plus loss. So the 7, you will determine na okay, kailangan ko palang i-reduce. And when you do that, pagka mag-a-adjust na naman yung losses mo kasi kanina pinilit mo yung 30 megawatts. So after that, you have to reduce your generation again, maybe adjust your generation until process of iteration hanggang sa naalala niyo naman yung problem natin, di ba? Hanggang minimal na lang yung difference. You'll eventually determine ito na yung final power flow solution. So medyo parang dating forced or brute force ang tawag dun sa pag-analyze ng power flow or pag-solve ng final solution sa power flow. So brute force. Pero when it comes to optimal power flow, kasi yung kanina power flow, you don't have an information kung sinong uunahin mo. Okay? Ikaw lang. You're feeding it to the software. But in an optimal power flow, similar to dating mga samples natin, you now have to integrate what do you call this, an input such as price. Magkano ba yung generation? Sino ba yung dapat kong unahin? Sino ba yung pinakamura? So, yun yung magiging input na eventually you have to determine ano ba yung objective mo. Just like what we have been doing in this class for the past first few weeks. You have to have an objective, and for you to accomplish that objective, which is minimize the cost, you'll have to know ano ba yung mga inputs for you to minimize the cost, and that will entail prices as well. Okay? Sige. Kailangan po-pause ko lang yung Okay, continuing. Since load flow, ang optimal power flow, now you're using optimization like we did in our class. Pero di ba dati, ang nakikita nyo lang more on dun sa problem natin before is ito yung functional cost ng generator, and eventually ito yung Pmin and Pmax ng gen. But we never, yun lang yung limits natin. Yung generator capacity, ang constraints natin are either generator capacity or supply and supply and demand. But now we're adding a new constraint, which is power flow or load flow. Now from then, malalaman natin, kunwari, if you are trying to minimize cost, and you're trying to schedule generators appropriately, the question is that generator schedule, yung mga generator schedules mo ba are feasible for you to implement considering yung power flow? Baka mamaya yung daloy ng kuryente ay na-overload na sa isang transmission line or transformer. So you have to consider that as well. And that additional constraint makes it more realistic or feasible. Okay? Now our objective is still, we want to minimize cost, but subject to an additional constraint. And this is the load flow constraint and transmission limits. Okay. Now, while doing this optimal power flow, itong next step ng ginagawa natin, we will be using what we call linear programming. Linear programming is a mathematical method used for determining a way to achieve the best outcome. So, in a given mathematical model, for some list of requirements represented as linear equations. Okay? So, naalala nyo naman, generator cost functions are quadratic. Next is losses are quadratic. Okay? Even yung power flow is quadratic ang equations niyan. However, sa ngayon up to until now, most software na binebenta for power system optimization that considers economic operations, most ng software are still linear. But what do we mean by linear? Nililinearize niya yung quadratic equations mo. Kasi it's much, as I've said in our first meeting, or first or second meeting, problems are easier to solve, okay? When solving it in a linear equation, di ba? Yung mga kunwari, 3 equations, 3 unknowns. Imagine nyo kung 3 equations pero quadratic, 3 unknowns. Medyo mahirap siya. So, nililinearize mo. Losses, even yung ating power flow are linearized. Okay? Now, what happens there? Pag nililinearize natin, obviously, you lose some sort of accuracy. Okay? You lose some sort of accuracy, but that accuracy may be minimal. It's still accurate. Diba? Dapat may certain level or tolerable accuracy yan. But ang kanyang ang kagandahan naman ay nasa-solve mo at a much faster rate. Okay? So, kasi kunwari quadratic equations, you have number of hundreds of variables. Then you will solve a quadratic equation in, let's say, kung ang software mo mabagal at hindi masyadong maganda yung infrastructure ng system mo. Ang tawag dito, you'll eventually solve in, let's say, 1 to 2 hours, which is counterproductive na if you're trying to run an optimization that hopes to produce a solution every 5 minutes or every hour. Okay? So, continuing, guys, nakalagay dito, no, may nag-prompt pa sa inyo na Zoom meeting will end in 10 minutes. Okay? Kasi free lang to. If biglang nag-cut to at nag-log out, just join back again. Okay? Re-log in ko na lang. Kailangan lang re-log in kasi free na account. Okay. So this is the LP standard form where you minimize your objective, say, subject to a set of constraints. Now, also part of what we will be using in linear programming, although hindi ito yung ginagamit sa commercial system, but for academic purposes, para maintindihan, we use what we call a DC power flow. Hindi ibig sabihin ng DC power flow means direct current, but in itself na parang you're modeling it after DC. Kasi kapag AC, you deal with angles, you deal with sinusoidal waves. However, if you recall, ito nakalagay sa bullets dito, no? This is the power flow equation for real power P and reactive power Q. Okay? But in the power system, guys, always bear in mind, lalo na sa mga transmission system, that the resistance is very, very small with respect to reactance. Okay? So what do I mean? Kasi lahat naman ng mga dinedesign na mga transmission line, syempre transformer, almost no resistance yan over unit length. Kasi transformer just has to have a coil and it doesn't really have a transmission line type na parang nagta-travel over long distances. But yung transmission lines normally are modeled where their resistance is very, very small. Syempre ayaw mo ng losses. Okay? Pero it's very, very small with respect to reactance. Okay. Going back also, in a realistic system, kailangan mo i-consider talaga yung R. Okay? Kasi like for example, here in Luzon, when before all of this happened, no, yung COVID na yan, we were our peak demand is around 11,000. We were trending towards breaching that peak demand again this year. Summer, usually summer yan. Lately, it's been around May to June, nare-reach yung peak demand, lalo na sa Luzon and even in Visayas. Kaso, given na ganitong predicament, where we're the commercial centers, industrial facilities, everyone is staying at home, and everyone is just utilizing electricity based on residential use or home use. Napakababa nun. Yeah, lately, if you check our demand, it's only around, roughly around 6,000 to 7,000. So, mababa, no? Laki na na-reduce. Okay? So, losses normally is, sa Luzon, is around 2% or less. So, if you account for 11,000, 2% nun ay loss, that's still significant, no? 220 megawatts. That's a very big, high amount of losses that you have to consider. Okay? So realistically, you have to consider losses. However, in this problem, we're omitting losses muna. We're dealing with power flow. Okay? Power flow in a transmission line. So when your R, and when we're dealing with power flow nga, and your R is small than X, very, very small, ito ang nakalagay, than the X value or reactance. Okay? Then, you can further reduce that into this equation. Okay? Even also that the angular difference between buses is very small. Siyempre, the closer you are to 0, the closer you are to the value of 1 or yung unity. Okay? So eventually, we'll get these equations for using a small angle approximation. Now, since your P, your real power is very, very high, obviously, to your Q. Now, we're trying to solve na lang una ay real power in a DC power flow. So, marami ka nire-reduce. Although, hindi siya realistic. Sabi ko nga, academic, no? Most commercial systems, like what we use here in WESM, napaka, realistic. So, hindi ito yung ginagamit. But again, for academic purposes, we can use this DC power flow model. Okay. Let us assume this network where we have 4 buses, bus 1, 2, 3, and 4, with 5 transmission lines. We have 3 generators here in bus 1, bus 2, and bus 4. Whereas we have 2 loads, which is one in bus 2 and another at bus 3. Now the lines, if you can see, nakalagay Y, no? This means hindi ito reactance. Nireduce na natin yung resistance, tinanggal na natin kasi again, going back, di ba? R is very, very small than X. So if you remember, yung ating computation for impedance, Z squared equals R squared plus X squared. Let's say yung R mo is 0.00001, 4 na 0, 1. Then your X is 0.2 per unit. if you get the Z, the eventual impedance, para yun naman talaga yung gagamitin sa power flow, you will come to a conclusion na yung value ng Z is close to the X, which is 0.2. Okay? So kaya mini-remove na natin yung R. However, yung R na yon, wala na yung R. Yung X, ang ginamit dito instead is admittance. You can see here, Y represents admittance. So pag Y for between bus 1 and bus 4, the line Y or the admittance between line, the admittance of the line between bus 1 and bus 4, which is Y14, is equal to negative J10. So ang reactance nito, di ba ang admittance naman is the reciprocal ng reactance. So ang reactance nito, 1 over negative J10, you will eventually get J 0.1. So yun talaga yung reactance. Okay. Now, for those who are familiar with the Y-bus, that's good. But for those, sige, parang dating, review to. If you have a Y-bus, we'll need to form a Y-bus, you have to have a square matrix. Square, ibig sabihin equal yung number of rows and number of columns. Okay? So, yung square matrix na kailangan sa Y-bus is dependent on the number of buses. Kaya nga Y-bus, no? So, we have 4 buses. So, we need to develop a 4x4 Y-bus. Okay? Now, in a Y-bus, you have to get for the diagonal elements, ito, nakita nito. No? Okay? For the diagonal elements, kunin nyo lang yung sum ng lahat ng admittance na connected doon sa diagonal element that will represent your bus number. Like for example, ito, diagonal element 1, ito. Okay? This represents bus 1. This one, bus 2, yung diagonal element 2, bus 3, then bus 4. Kunin nyo lahat ng admittance connected to bus 1, that will be the value of your first diagonal element. So lahat na connected dito, itong line na to, galing bus 4, galing bus 2, and galing bus 3. Ito yung mga line na connected sa bus 1. Get the sum, that will be negative J30. Okay? For the off diagonal, it's basically just getting the admittance with that represents the line. So kunwari ito, row 1, itong element na to, no? Yung pangalawa, row 1, column 2. So sa row 1, column 2, what is the admittance for the line that connects bus 1 and bus 2? Kunin nyo yun, times negative 1, you'll get, ayan, from bus 1 to bus 2,